Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about distribution and density functions of random process. Distribution functions of a random process and density functions of a random process. In previous chapter, we have already discussed about distribution and density function of a random variable. So now here we are going to discuss about distribution and density functions of random process. And what is a random process? Random variable is a function of time. The random process is a continuation of the random variable. So random variable is a function of time. It's called a random process. So random variable can be determined from a random process at a particular instant of time t. The random variable has all the statistical properties. So the statistical properties of the random variable are mean, movement, variance, etc. So that are the statistical properties of the random process. So the random variable has all the statistical properties that are related to its probability density function. If two random variables are determined from the random process at two different times t1 and t2, they will have all the statistical properties of mean value of the random variables, movement value of the random variables, variance of the random variables. So related to their joint probability density functions. So first we are going to discuss about joint distribution function of a random process. So consider a random process x of t for a single random variable at a time t1. So x1 is equal to x of t1. So x1 is the random variable. That random variable varies with respect to that random variable at a time t1 is x of t1. So that is x1 is equal to x of t1. So the cumulative distribution function of a random process x of t is given by or defined as fx of x1 comma t1 is equal probability of x of t1 less than or equal to x1. So the cumulative distribution function of a random process x of t is denoted as fx of x1 comma t1. x1 is the value of the random variable. Capital X is the random variable. X1 is the value of the random variable. So at a time t1 is the random process is x of t1. For two random variables at a time instance t1 and t2, so that are x1 is equal to x of t1 and x2 is equal to x of t2, the joint distribution is called the second order joint distribution function of the random process x of t. So the second order joint distribution function of the random process x of t at the time instance t1 and t2 is denoted as capital Fx of x1 comma x2 comma t1 comma t2, and it is given by or defined as fx of x1 comma x2 comma t1 comma t2 is equal probability of x of t1 less than or equal to x1 comma x of t2 less than or equal to x2. So x of t1 and x of t2 are the random process of the random variables at the time instance t1 and t2. Small x1 and small x2 are the values of the random variables x1 and x2. So this is the definition of the joint distribution function of the random process x of t, where small x1 and x2 are the real numbers. And this is the definition of the first order probability distribution function or cumulative distribution function of the random process definition. And this is the second order probability distribution function definition. So similarly, the nth order joint distribution function of the random process x of t definition. In general, for capital N random variables at capital N times, so that capital N random variables and capital N times are x of ti is equal to x suffix I. X of ti is equal to xi, where I is equal 1, 2, 3 and so on. So that random variables are x1 is equal to x of t1, x2 is equal to x of t2, x3 is equal to x of t3 and so on, xn is equal to x of tn. So n random variables at n time instance. The nth order joint distribution function of the random process x of t is given by or defined as capital F suffix x of x1 comma x2 comma x3 and so on xn comma at the time instance t1 comma t2 comma t3 and so on tn is equal probability of x of t1 less than or equal to x1 comma x of t2 less than or equal to x2 comma and so on x of tn less than or equal to xn. So this is the definition of nth order joint distribution function of the random process x of t. And next we are going to discuss about joint density function of a random process. And what is the density function? The density function of the derivative of the distribution function of the random process. The density function is the derivative of the distribution function. The joint density function of a random process can be determined from the derivative of the distribution function. So the first order density function of a random process x of t is given by or defined as. So Uh, the first order density function of the random process x of t is denoted by symbolically small f suffix x of x1 comma t1 and it is given by fx of x1 comma t1 is equal to d by dx1 into fx of x1 comma t1. So now here capital X capital fx of x1 comma t1 is the first order distribution function of a random process x of t. Small fx of x1 comma t1 is the first order density function of a random process x of t. So this is the definition of first order density function of a random process. The first order density function of a random process is the derivative of the first order distribution function of a random process. Similarly, the second order joint density function of the random process is the second derivative of the joint distribution function of the random process. So that is small fx of x1 comma x2 comma at the time instance t1 comma t2 is equal second derivative dou square by dou x1 dou x2 into second order distribution function of the random process x of t at the time instance t1 and t2. So this is the second order joint density function of the random process x of t definition and its mathematical expression. Similarly, the nth order joint density function of the random process x of t is given by fx of n random variables at the time instance that is fx of x1 comma x2 comma x3 and so on xn comma at the time instance t1 comma t2 comma t3 and so on tn is equal nth derivative that is dou power n by dou x1 dou x2 dou x3 and so on dou xn into nth order joint distribution function of the random process that is capital fx of x1 comma x2 comma x3 and so on xn comma t1 comma t2 comma t3 and so on tn. So this is the nth order joint density function of the random process mathematical definition. If x of t is the discrete time random process, then nth order probability mass function is px of x1 comma x2 comma x3 and so on xn comma at the time instance t1 comma t2 comma t3 and so on tn is equal probability of x of t1 is equal to x1 comma x of t2 is equal to x2 comma and so on x of tn is equal to xn. So this is the discrete random process nth order probability mass function definition. So this is the concept of distribution and distribution function and density function of the random process x of t.